Grade 10, so we're going to look at photons today. Quick reminder, we did vaguely touch on that when we looked at electromagnetic radiation. It is a particle or quantum of electromagnetic radiation. So photons is what we talk about when we talk about the particle nature of light or of all electromagnetic radiation. Now, electromagnetic radiation is excuse me, electromagnetic radiation is they are transversal waves. As soon as we deal with waves, I don't want you to forget these two formula. We can still use wave speed equals f lambda and frequency is equal to 1 over period. Okay, please don't forget these. These are still applicable in this section. But in this section, we now have two new formulae that only apply to electromagnetic radiation. Okay, I cannot emphasize this enough. The next two formulae I'm going to show you only apply if they've specified in the question that we are dealing with electromagnetic radiation. So these two formulae are E equals HF and E equals HC over lambda. So I will go through what these mean. Okay, so the E, that is, I think this is on your printout. Yeah, this is on your printout. Okay, E is the energy of a photon of electromagnetic radiation. Sorry. So E, energy of photon. Energy is measured in joules. Okay. We've also got H. So you've seen one constant already. We saw that when we did electromagnetic radiation 2 days ago. That constant was this one, C. So here's your second constant. It will be on your formula sheet. It is Planck's constant. Okay, and it has a value of 6,63 times 10 to the negative 34 joules seconds. Yeah, joule seconds. Okay, and you have to, please make sure that you find this on your formula sheets and that you know that this is what that H value is. Whenever you see H, when we substitute in a value, it is this value every single time. Okay, then the next one, F. Frequency, same as with in these equations. Okay, F is frequency measured in hertz or sometimes per second. What else have we got? C, that is the speed of light or any electromagnetic radiation, and that is also a constant, 3 times 10 to the 8 meters per second. And the last one, lambda, wavelength, just like it is over here. Okay, and that's measured in meters. Okay, and that's basically all there is to the section. You can be asked to identify the type of electromagnetic radiation that you're dealing with based on either its frequency or its wavelength. If that is the case, you will usually be given some values to work from. Okay, but the example that I'm going to do, the examples we're doing are in your printout. So there's a little subheading examples with 4 questions and then questions underneath it. Those are the questions you do by yourself. Okay, so we're going to start the examples. I just want to pause you there so I can make some space. Okay guys, so at the top in black I've written down the 4 formulae that apply to this section. Okay, so another quick reminder, these 2 apply to all wave scenarios. These 2 only apply to electromagnetic radiation, and then these are the 2 constants for this section. Okay, so the example we're doing, we've got a photon of unknown electromagnetic radiation. So we don't know, it could be visible light, it could be X-rays, it could be gamma rays, it could be microwaves, it could be any type of electromagnetic radiation. And we know that it has a period of 3,21 times 10 to the negative 17. So let's quickly write down that in symbol form. Okay, period, remember that is capital T. So we know that T equals 3,21 times 10 to the negative 17 seconds. Okay. Now, question A asks us to determine the frequency of the wave. So we have period, okay, and we're looking for frequency. So what you always do is you write down what you know, you write down the symbol of what you don't know, and you pick a formula that's going to help you get there. So we know period, we want frequency. So we want a formula that's got T and F in it. So that's going to be this one here, okay? So we're going. Period equals 1 over frequency. We know our period, that's 3,21 times 10 to the negative 17, that equals 1 over frequency. I know you guys struggle a little bit still with solving equations, so I'm going to help you with this one, but then from now on you need to try it yourself. Okay, so whenever I've got a fraction on one side and just one thing on the other side, I put it over 1 and I cross multiply. So we're going to have 3,21 times 10 to the negative 17 f equals 1 times 1 is 1. Okay, and then we'll divide both sides by the coefficient of f to get f alone. So we're going 1 divided by 3,21 times 10 to the negative 17. Oopsie. Yep, there we go, which is, oopsie. Sorry. 3,21, yeah. Which is 3,12 times 10 to the 16, and remember frequency is in hertz. Okay, then question B, they want the wavelength. Okay, so we want to pick a formula that has wavelength in it, so that's an option, but we don't know the energy, so we're not going to be able to use this equation to get lambda. That's one. Do we know frequency? Yeah, we just worked it out. Do we know this wave speed? Bit of a tricky one. V, they haven't told us anywhere what the speed of this wave is, but they've told us that it is electromagnetic radiation. And with all electromagnetic radiation, it travels at the speed of sound in a vacuum, which is 3 times 10 to the 8. Okay, so we can actually use this formula. We can say that V equals F lambda, where V is C. So we can substitute that as C equals F lambda and now solve for lambda. So we know the wave speed is 3 times 10 to the 8. We know the frequency is 3,12 times 10 to the 16, and we're looking for wavelength. So we're going to divide both sides by this coefficient of wavelength. So we've got 3 times 10 to the 8, divided by that coefficient, and we get 9,63. So our wavelength is 9,63 times 10 to the negative 9 meters. Okay. Question C. What is the energy of the photon? Okay, now here we can actually, okay, so we want the energy, right? So we have to use either that formula or that formula, and we can actually use either, because here we know H and we know F, so we can use this formula. And here we know H, we know C, and we know lambda. We've just worked that out. So we can also use that one. But to me, that one looks a bit friendlier. So I'm going to go with that one. So I've got energy equals Planck's constant times frequency, which is 6,63 times 10 to the negative 34 times 3,12 times 10 to the 16. Hoping you guys got a little bit confident with using scientific notation in your calculators. So 6.63 times 10 to the negative 34 times 3.12 times 10 to the 16. And I get 2,07 times 10 to the negative 17. It's energy. Energy is measured in joules. Okay, and one last question, question D. Identify the type of electromagnetic radiation. Okay, so they're asking, is it gamma? Is it ultraviolet? Is it X-ray? Is it microwave? Is it visible light? What is it? So for that, we need to look back. In a test or an exam, you'll be given a spectrum, okay, with the wavelengths and the frequencies labeled on there. But for now, you're going to look back at the electromagnetic radiation note where you were given the spectrum. So on that we've got wavelengths labeled, okay? Now our wavelength is of magnitude 10 to the negative 9. So you need to look on that spectrum what electromagnetic radiation has wavelengths of times 10 to the negative 9. What type of electromagnetic radiation will have a wavelength of the magnitude 10 to the negative 9. And on that you'll see for X-rays X-rays ranges from, I think, 10 to the negative 8, oopsie, 10 to the negative 8 up until 10 to the negative 11, which means 10 to the negative 9 lies in that range, which means that this photon is a photon of X-ray. Okay. Yeah, I think that's fine. Just a quick note on the section, often they're going to give you information in the wrong units. Okay, so for example, they might give you a wavelength in micrometers. Then you need to remember to convert this to meters. Okay, I did give you a conversion page, that unit conversion landscape page that I asked you to stick either in the front cover or in the back cover of your physics book, so you should find it there. It's just a matter of sticking a little conversion factor on the end. Okay, so I'm going to leave you here. You're going to do the photons questions for me at the bottom of that photons page. Let me know if you get stuck, please. It's been very quiet. I haven't heard much from this group, so please let me know if you are stuck.